see my nigga Coolio put me up on the game when I step through the door. You know, some of these niggas is so deceptive, using my styles like a...
Okay, for this question, we're going to suppose that the gradient of f at p is equal to 2, negative 4, 4. And the question asks, is f increasing, is our function increasing or decreasing at p in the direction of v equals 2, 1, 3? So basically what we're doing here is seeing if f is increasing or decreasing. So that would mean, as a physical application, what are we asking for? We're seeing what is the sign of the slope of the tangent line at this point p in that direction, okay? So we're trying to see is slope of tangent line at p in the v direction, is that positive or negative, right? So recalling, so that's our question really. So what is the slope of the tangent line when we're given a direction and a point, right? That would actually be, that's given by the directional derivative, right? So directional derivative, this is the key here. So that's what we're going to use to figure out this problem. So the formula for the directional derivative is d sub u of f at p is equal to the gradient of f at p dotted with v, our direction vector, divided by that magnitude. Okay, so what we're going to do is just compute this, and then we'll see what sign we end up with, and that'll tell us whether f is increasing or decreasing at the end. Okay, so first of all, we have v. All right, so we have this guy, that's good. We do have this, that's already given, so that's good. Now we just need to find this magnitude here. So to find the magnitude, we're going to take each of the components, we're going to square them, okay? And we're going to add them all together and put them under a square root sign. So the magnitude of v is going to turn out to be 2 squared plus 1 squared plus 3 squared, so that's 4 plus 1 plus a 9, okay? So that's going to be a 14, square root of 14 there. Alright, so now we have all of the parts that we need. So we're just going to plug these in and find the directional derivative. Okay, so f of p is equal to 2, 2, negative 4, 4. And we're going to dot that with our direction vector, so 2, 1, 3. And this is going to be all over the square root of 14. Okay, so here, this is going to be, continuing on, we have a 2 times 2. Okay, so we have 2 times 2 plus negative 4 times a 1 plus 4 times 3, and this is all over the square root of 14. Okay, so here we see that we have, well, I guess I'll just continue this on the next slide. Okay, so we have that the directional derivative so far is equal to 2 times 2 plus negative 4 times 1 plus that 4 times 3, okay? And this is over the square root of 14, okay? So if we continue this, we get 4 minus 4 plus a 12, okay? And this is over, again, square root of 14. So the 4's cancel out, and we just get a 12 over square root of 14, which is a positive number, right? That's greater than 0. So since the, and I'll just write it as this, since the directional derivative at p is a positive value, then f must be, then our function f must be increasing at this point in the v direction. Must be increasing at point P in the v direction. Okay, that just about does it for this practice problems video. I hope that helped, and happy studying.
It's a crazy, it's a doggy dog.